Hello everyone, welcome back to my channel. My name is Sanjeev Garg. So today we are going to discuss about the dynamic programming. So next question is frog jump. This question is similar to the Fibonacci series and the staircase problem that we have already discussed in the previous videos. So if you have not watched my previous video, I highly recommend you to watch my previous video so that you can easily understand these questions. Okay, so let's get started with this question. So frog jump. Let's first read the question. There is a frog on the first step of the long staircase. A frog wants to reach to the nth stair. A height of I is the height of the I plus stair. If the frog jumps from the ith to the jth stair, the energy lost in the jump is given by the absolute value of the height of I minus 1 minus height of j minus 1. If the frog is on the ith stairs, he can jump either to the I plus 1 stair to the I plus 2 stair. You can find the minimum number of the total energy used by the frog to reach from the first stair to the nth stair. If you see, there is similar kind of the pattern that the frog can take either one jump or can take from two jump, and frog wants to start from the first position to the nth position. So in this there is one twist is there. In the previous question Fibonacci series or the staircase problem, what we were doing, we were trying to find the total number of the ways to reach from the bottom to the top. Now we are not going to find the total number of the ways from the bottom to top. We have to find how much energy is lost from the bottom to the top basically. So let's see the example first. Okay, so let's try to understand the example first how this works. So frog jump, let's say frog jump. Okay, let's say frog jump problem. Let's take the same question that is given in same example that is given in the question. Okay, 10, 20, 30, 10. Now let's say frog is at this position. Okay, now frog can take either one jump or frog can take two jump. Okay, let's say, okay, so if frog take one jump, so energy loss will be 20 minus 10 will be 10, and here the energy loss will be minus 30 minus 10, that will be 20 only. So minimum of 10 and 20, minimum of 10 and 20 is 10. So frog will be here. Now frog can jump from one jump or frog can take two jump here. So if the frog is taking one jump, then 30 minus 20, that is 10, and here is 20 minus 10, that is 10. So total energy loss will be 10, this one plus this one 10 plus 10 is equal to 20. So total from this position through this position, third position, total energy required is 20. Total energy required is 20. So let's see in the hierarchical form. Let's say if we have a function f4 signifies that how much energy is required to reach from the bottom to the f4, how much energy is required. So how we will proceed this, we will proceed in the same manner as we did in the previous questions like Fibonacci series or the staircase problem. So what the f4 says that f4 will ask to f3, f4 will ask to f3 and f2. f4 will ask to the f3, hey, how much energy is required to reach at you, energy is required to reach at you. Let's say f3 says that I require 4 energy to reach at me, and f2 says that I required 5 energy to reach at me. So now f4 will says, okay, so 4 energy is required from here, 5 energy is required from here. So 4 plus energy required from f4 minus f3. Similarly this one 5 plus energy required means energy required 4 minus f of 2. So basically this is this is the energy given by this f3, this is the energy given by this 2, and one more jump, this one from this one, one more jump from this f2 to f3. So energy required for this one is as well. So this is the total amount of the energy that will require from f3 to f4, f2 to f3. So minimum of this one and minimum of this one will be the answer for the f4. So let's say to make this complete graph. Okay, so f4 will ask to f3 and f2. Similarly, f3 will ask to f2 and f1. f2 will ask this to f1 and f0, and this f2 will ask with f1 and f0. Similarly, this f0, this one is f0. Okay, let's say if we have only one stair, so frog is here. So how much energy is required to reach from 0 to 0? Definitely 0, definitely 0. So here it will give 0. Okay, it will give 0. This is 0, this is 0, it will pass 0. So energy required for f this is also f0, so it will give 0. So energy required to reach at f1. F1 will ask to the f0, hey energy, how much energy is required to reach at you? F1 will f0 will say 0 plus energy required from f0 to f1, so means f of 1 minus f of 0. So how much given? 20 minus 10, that is 10 only. Okay, 20 minus, so 10 plus 0 is, that is 10 only. Similar to the other level as well. Okay, in this way at every node we have the two options. Okay, two options means we have to go with the two ways. Now if we can see this as, we can take as one node we require to calculate, one function we require to calculate here, two function we have to require to calculate here. Here 4, in the worst case 8 will required here. So we can write simply 2 raised to power 0, 2 raised to power 1, 2 raised to power 2 and 2 raised to power 3 here. Okay, so if I write in the same single line, that is 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 up to 2 raised to power n. So this is something like GP series. So time complexity will be order of 2 raised to power n only, and space complexity is same order of 2 raised to power n only. So if you see how the stack will work in this case, the same thing. To calculate the f4, first this will put into the stack. To need to calculate the f4 we need f3, to calculate the f3 we need f2, to calculate the f2 we need f1, to calculate the f1 we need f0. Once f0 is calculated, okay, it will come out from the stack and its values go to the f1. F1 is also calculated. Now to calculate the f2 we need f1. Okay, to calculate the f2 we need f1, and now again f0 we will put into the stack. Now f0 is also calculated, f2 is calculated. Now to calculate the f3 we have already calculated f2. Now we will put f1 into the stack. To calculate f1 we will again put f0 into the stack. Okay, similarly all these function we are going to put into the stack at least once. So that's why total functions are 2 raised to power n. So the time complexity is 2 raised to power and the space complexity is also 2 raised to power n. Okay, so one more thing, if you see in this, I already explained in the previous example as well. Now let's, if you see, okay, if you see this f0 is here, f0 is here, f0 is here, f0 is here, f1 is here, f1 is here, f2 is here, f2 is here. These are the overlapping sub problems. So how can we resolve this? Instead of calculating these values, these functions again and again, there is no need to recalculate it again. We can store it into an array. So basically what we will do, we will do the memoizations. How we will do the memoizations? Okay, so let's say we at f4 we have to calculate f4. To calculate the f4 we need f3, to calculate the f3 we need f2, to calculate the f2 we need f1, and then we need f0. Okay, so we already know that f0 is 0 with the help of 0, and we are taking the one array as well. Okay, we are taking the an array as well, f of 0, f of 1, f of 2, f of 3, f of 4. Okay, so we are keeping one array as well. F of 0 is calculated, so we will put its value is in the f of 0. So f1 is calculated, let's say its calculated value is 2, we are putting 2. Now to calculate the f of 2 we need f1. Again we need f1. Before calculating the f1 we will check first if f1 is present or not. If it is present there is no need to call this function again. So f2 is calculated. Let's say if calculated for, now f2 need to calculate the f3 we need f2 and we need f1. Before calculating the f1 again we will check if f1 is present or not. Yes, present, so there is no need to calculate it again and again. So at first we will calculate this function f4, f3, f2 and f1 only once. So sorry, the time complexity will be order of n only. Similarly for the space complexity, if you see how the stack space will work in this case, in this ways, first we will put functions 4, then 3, then 2, then 1 and then 0 into the stack. Once it is calculated it will never be put again into this stack. So similarly for f1, f2, f1 and f4. So time complexity is order of n, space complexity is stack space, that is order of n, that is stack space plus order of n for the array that we have taken, this array. Okay, so it is nothing other than order of n only. So this is called memoization. Now if you see we are using this stack space, can we reduce this stack space? Okay, can we reduce this stack space? So how can we reduce this stack space? The stack space is created by the recursion. So if you see the same pattern in the problem, that we can go only one step or the two step. So what we will do in, while calculating this dp array, okay, so function of 0 we already know, this is 1, this is 2. To calculate this we only need this one. So we can join at this first step, this is 0 index 1 2 3 4. At the first index we can only take one jump, because if we go to the 2 jump then the value will be negative. So we can easily calculate this value plus this minus this. Let's say this is calculated 4. Now to reach this, to calculate the function 2, we can take one jump or we can take two jump. Okay, minimum of this we can write here. Similarly for this. So now we are iterating here. We are not taking any jump, or we are not taking any stack space here. So here the time complexity will remain same, because every function, because we have to fill this array anyhow, we have to take the order of n time only. Okay, and the space complexity is order of n because of array, not because of recursion. So we have reduced the space complexity from 2n to the n. Can we reduce this furthermore? Can we reduce this to the order of 1? Yes. How can we do this? We have already done the same thing in the previous videos. How we if you see in this array, to fill this array, let's say this is function of 0, this is function of 1, this is function of 2. Okay, we already know the value of this. This depend on this previous one, this depend on this one step, and this depend on 2 step. Means just 2 previous, this is, let's say this is previous 1 and this is previous 2, and this is what exactly I am current at. Okay, let's say this is current position. Okay, now what I need the previous value. Once the value is filled, my previous 2 will go here and current previous 1 will go here. Okay, so in this way we are taking just 3 variables, current, or we can say result, previous 1 and previous 2. So order of 3 only. Order of 3 is nothing but order of 1 only. So this is the space complexity. Okay, I think you got better understanding now also. Okay, so let's try to run the program. Now let's try to run the program and try to understand with the help of the program. Okay, so now first step is just remove this one, and same thing we are going to do is for jump util. You have to make util function here, and in this just return frog jump util. Let's copy here and paste, and we are passing n and heights. Okay, base case is same as if our n is less than equal to 0, means we already know that there is no energy required, so simply we'll return 0. Else we will return return frog jump util of for n minus 1. Okay, so if you see what we are doing now, I can take one jump. Okay, so how can we take one jump? Okay, so let's say I'm at 4. How I reached at 4 is from the first from the third position, means I will ask to my previous one. Previous one means n minus 1. Hey, how much energy is required to reach at you? And will pass the height here. Plus, if this is the one that asked, after that one jump is required from that position to the my exact position, so it will require math dot absolute heights of n minus heights of, let's say, n minus 1. Okay, so this is the first jump. Okay, let's remove this, else we can remove this one because everything will run definitely sure. Okay, for the second jump, let's say I'm at the first position. Okay, I can go to the 0th position, means I reach the first position from the 0. So to do the second jump, first I will check if I can take second jump only if my n is greater than 2, sorry, n is greater than 1, only then I can take the second jump. Now our second jump is, so let's take a variable second jump, int second jump is equal to, as we have to calculate the minimum loss energy, so we'll take the maximum value here. Okay, second jump equal to, let's copy this function, this line same as it is. Okay, instead of minus 1, now I will ask to the second one, hey, what are the energy required to reach at you? Okay, now I will return simply math dot, because I have to calculate the minimum energy required to reach at that position, so it will be one jump and the second jump. Let's do it fast. Okay, n minus 1, and let's check once. Okay, everything is working. Okay, everything is good here, so let's try to run it here. Okay, so if you see, and we are taking the index, I think, yes, we are taking the value from the 0 to n minus 1, so we'll put n minus 1 here. Compilation done. Yes, all the 3 test cases are working fine. Fourth one is time limit exceeded, because we already know that this is a recursion and it's taking 2 raised power n time complexity. So how can we reduce? By the memoization. How can we define the memoization? Just dp is equal to new, take an array of dp is equal to new int, as we are taking the index from the 0 to n minus 1, so there is no need to take the n plus 1 because we are starting from 0. Okay, so and now arrays dot fill, Okay, arrays dot fill, we will fill the dp with the maximum value. Okay, integer dot max value. Okay, integer dot max value. Now we will pass the dp here, same int dp here. Now we will pass dp here, now we will pass dp here, and before calculating it again we just need to, okay, so dp of n will be this one. Okay, so we are doing this one, and before calculating it we need to check if dp of n is not equal to integer dot max value, then we'll simply return okay, dp of n. We are simply returning dp of n. Okay, so now let's see, one jump we have calculated, two jump, and before calculating we are putting into the n. Okay, dp of n, dp is there and we are taken the n. Okay, so 0 to n, if n is less than equal to 0 we are returning 0. If dp of n is less than equal to integer dot max value, we are using this dp of n. N is there, n minus 1, that's great. Let's run this. Okay, okay, let's try to submit this. Okay, so we are able to submit this. Now if we see, we are using recursion here, that is taking extra order of n space. Let's try to remove this. How we can do this? With the help of tabulation. In tabulation we will just remove this one. Okay, we will remove this one, and we need a for loop. Okay, for, we know that dp of 0 is equal to 0. dp of 0 is equal to 0 for int I equal to 0, I is less than, okay, so 0 is already we have declared, I is less than equal to n, I is less than equal to n, and I plus plus, okay, I is less than equal to n, I plus plus. What we will do, we will calculate it. Okay, so one jump, two jump, just need to copy this one and need to paste this one here. Okay, now let's remove this one and simply we will return dp of n here. Okay, so here n is there, dp of 0 is equal to 0, for I is equal to 1 to n, n is already n minus 1, so we are running the loop from the 1 to n. One jump, so okay, we have to calculate for n. Now remove this one, dp of n minus 2. Okay, dp of n minus 1, one jump, and second jump dp of n minus 2 we have calculated. Okay, now this for loop will close here, so we will put dp of I equal to dp of I equal to math dot minimum of one jump comma second jump, one jump comma second jump. This is dp of I minus 1 because we are starting the loop from the I. This is I. Okay, so index we have changed from I. This is I. This is also I, and this is also I. Okay, so I think now it should work. From 1 to n we are running the loop for n. Okay, so let's run this. Okay, so one jump. Okay, so that's working fine. Let's try to submit this. Okay, so this is submitted. Now next approach is, now we have to remove this extra order of n space as well. How can we do this? We can use variables, two variables basically. Okay, let's remove this dp, let's remove this dp from here as well. Okay, so let's remove this dp from this dp from. Okay, so what we will do, we will take a int result equal to 0, int my previous one equal to 0, and int my previous 2 equal to 0. There is no need of this dp. So if I'll take the one jump, I will ask to my previous one, because I don't need to go to the second one. I will ask to my previous one that, hey, what is the value to reach at you? Now for the second, I will ask to my previous two, and this is the result that we got. Okay, this is the result we got. Now my previous one will move to the next one. Next one means result, and my previous two will be my previous one. Okay, now we will return result only. Okay, so now we are not giving the dp array here, n minus 1, everything is good. Now let's try to run this. That's working fine. Okay, yes, we are able to submit this as well. So now if you see how we resolved this, basically how we optimize the solution from 2 raised power n to order of 1 in case of space complexity, and 2 raised power n to the order of n in case of time complexity. This is the way how the dynamic programming works. Okay, so next question is just similar to this question, just one modification that I am going to do here. If you see, you can take the 1 jump, 2 jump. What happens if we say that you can take 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump, up to k jumps? Think about it. How can you solve this problem? So until then, do subscribe, please like, please share my channel, so that I can make more informative videos for you. Thank you guys.